Hi, as part of today's lesson, you've been learning how to do acid-base titrations and also how to calculate unknown concentrations from information that we've got from doing our titration experiment. In this worked example, we've got a typical exam question. Now, they can look a little bit confusing at first, as there's a lot of information that's given in just a couple of sentences. So my first tip would be to highlight all the useful information linked to the alkali, in this case sodium hydroxide. And in our question we've been told the concentration of our sodium hydroxide, that it's known to be 0.200 moles per decimetre cubed, and also the volume that was used in the titration. So this is our standard solution, our sodium hydroxide, and this has been placed in our burette, and we've used this in our acid-base titration experiment. We've also used 25 centimetres cubed of sulfuric acid, but we do not know its concentration, and that's what the question's asking us to find out. So once we're familiar with our question, it's time to organise all that information into a sort of workable method for you to use and work out the relevant information. So first thing you would do is write out your equation, which is 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid, H2SO4, to make a mole of sodium sulfate salt and 2 moles of water. Obviously, because these are a strong acid and a strong base, sodium hydroxide and sulfuric acid, the anions and cations in both will all dissociate and dissolve in water and be floating around as Na pluses, OH minuses, H pluses and SO4 2 minuses. The next stage would be to work out your ratio R. This is the R stage, our molar ratio. And from our balanced chemical equation, we can see that 2 moles of sodium hydroxide react with exactly 1 mole of sulfuric acid. And that will happen at your equivalence point. You will have had exactly 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid. So underneath your molar ratio, it's time to start using the data that you highlighted in the exam question. Now for sodium hydroxide, we know its concentration, 0.200 moles per decimetre cubed, and we also know the exact volume, our mean titer, is 23.40 centimetres cubed. So to work out the moles of sodium hydroxide, you just multiply the concentration by the volume. And the volume has to be converted to decimetres cubed. And to do this, just divide the centimetres cubed by 1,000. Now, a handy tip at this point when using your calculator is to put brackets around the fraction, so that when you type in the 0.2 multiplied by 23.4 over 1,000, put a bracket before that and after that fraction, so that you get the right answer. And the moles of sodium hydroxide are 4.68 times 10 to the minus 3 moles. That's given to us in standard form. That's the times 10 to the minus 3 notation there. If you want to convert that to digital, just decimal form, you just move the decimal place back to the left 3 places. So your moles is 0.0468 mole of sodium hydroxide. Great, we know our moles of sodium hydroxide. We've already picked a mark up to answer this question. That will get you a mark. Just calculating moles of something will get you a mark. Next step is to use that ratio to deduce the moles of sulfuric acid. Now we know that for every 2 moles of NaOH, we need 1 mole of H2SO4 to complete the neutralisation reaction. So we just divide the moles of NaOH, 4.68 times 10 to the minus 3, divide that by 2 to get our moles of sulfuric acid, because we've got half as much H2SO4 as NaOH at the end point of our reaction. our equivalence point to be precise. Good, we've got moles of sulfuric acid, that's great. We know the exact volume of sulfuric acid that we had in our conical flask, and I've converted that to decimeters cubed just to make the calculating that little bit easier and make it correct. So that's 0.0250 decimeters cubed of sulfuric acid. And now we can finally calculate our concentration in moles per decimeter cubed to start with. So to do the mole per dm cubed, you just divide the moles of sulfuric acid by the dm cubed. So the concentration of our sulfuric acid, 2.34 times 10 to the minus 3, divided by 0.0250. And that gives us our concentration 0.0936 mole per dm cubed. I've given my answer to 3 significant figures. The reason I've done that is because if you look at the data in the question that you highlighted, the least accurate data is given to 3 sig figs. And that is the concentration of sodium hydroxide, 0.200. That's 3 sig figs. So that means that we need to give our answer to no more than 3 significant figures. The question's also asking us to calculate the concentration in grams per decimeter cubed. To do that, you need to convert moles to mass. So we want our concentration in grams per decimeter cubed. Convert the moles of sulfuric acid that you calculated to a mass, and to do that you multiply it by the relative molecular mass of H2SO4, which is 98.1 grams per mole. So multiply the moles of sulfuric acid by 98.1, and then again divide it by the volume in decimeters cubed, and that will give you your concentration in grams per decimeter cubed, which I've calculated to be 9.18 grams per decimeter cubed. And again, that's given to 3 significant figures. Brilliant. Okay, you've picked up 4 marks now. 1 mark for calculating the conc in grams per decimeter cubed, 1 for calculating it in moles per decimeter cubed, and a mark for using the ratio correctly to deduce the moles of sulfuric acid. And the original mark, that first mark you picked up, would have been for calculating the moles of alkali, sodium hydroxide, in this question.